section 10-0 number lines. This is not actually a section in your book, so that's why we label it as 10-0. We're combining it with the rest of chapter 10, but you won't find it in your math book, but it is something that you guys need to know for your MCAs, so that's why we're covering it. There is a number lines topic on Study Island that you can do as well that goes along with this. Essential question: how do you locate a square root on a number line? So first of all, the square root symbol looks like this. I could put a variable in there if I wanted to. So that means I'm taking the square root of x. Square root is any number times itself. So a number times itself, you can take the square root of it and get that number again. We'll show examples in a couple slides here. Perfect squares mean, for example, the square root of 9. The square root of 9 is 3, because 3 times 3 is 9. The square root of 16 is a perfect square, because 4 times 4 is 16. Now if I give you, for example, the square root of 11, no number times itself can give you 11, so 11 is not a perfect square. So there's 2 examples of perfect squares and 1 example of not a perfect square. Integers, I always say, are numbers you can find on a number line. So they're positives and they're opposites. So for example, -3, -2, -1, 0, 1, 2, and 3. No decimals, no fractions. Are these numbers perfect squares? Explain your choice. So we're going to go through each one of these numbers and say, is there a number that I can times by itself to get each number? So 25 is yes, because 5 times 5 is 25. 16 is yes, because 4 times 4 makes 16. 18 is no, because there aren't 2 of the same number that you can multiply to get 18. 9 is yes, because 3 times 3 is 9. 100 is yes, because 10 times 10 is 100. 6 is no, there isn't 2 of the same number that you can multiply to get 6. 24 is no, there isn't 2 of the same number you can multiply to get 24. 40 is no. 49 is yes, because 7 times 7 makes 49. 64 is yes, because 8 times 8 makes 64. 55 is no. 81 is yes, 9 times 9 makes 81. 36 is yes, 6 times 6 is 36. 75 is no. 90 is no. 1 is a little tricky, but 1 times 1 is 1, so it's yes. 2 is no. 15 is no. And 3 is no. So yes means a number times itself gives you one of those numbers in the circle. So if I write it out, this was 6 and 6, 7 and 7, 5 and 5, 9 and 9, 3 and 3, and so on. They're all the same number being multiplied by themselves. All right, name the first 10 perfect squares. So if I make a list over here from 1 to 10, so 1 squared is 1. If I take the square root of 1, I get 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. And those all go in opposite order too. So square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. So it kind of goes both ways. And if I wanted to, if this helps, you can always put the squares in there to see how we're getting from one to the other. But you can take, for example, 5 squared and get 25. You can take the square root of 25 and get 5. These are not perfect squares. So these are all numbers that if you multiply them by a number by itself, you can't get any of these numbers. Find the integers that they lie between and graph them on a number line. So if I take my list from the other page, so 1, 4, 9, 16, 25, 36, that should cover all of these. So the square root of 17 falls in between 16 and 25. The square root of 16 is 4, the square root of 25 is 5. So that means that 17 is in between 4 and 5. Now if I look, 17 is closer to 16 than it is 25. So I'm going to have it be closer to the 4 than the 5. Maybe right around here though. Negative square root of 24, well 24 would fall in between again, 16 and 25, but this time it's going to be negative. So that means it's going to fall between negative 4 and 5 because of that negative sign. So I'm going to move that down here. Square root of 5 falls in between 4 and 9. 4 and 9, the whole numbers are 2 and 3. So I'm going to put the square root of 5 in between 2 and 3. Square root of negative 2, 2 falls between 1 and 4. So square root of 1 is 1, square root of 4 is 2. So but it falls between negative 1 and negative 2. Square root of 22 is between 16 and 25, which is 4 and 5. So I've got 2 that fall between 4 and 5 now, which is okay. I'll just stack them on top of each other. And 11 falls between 9 and 16, which is 3 and 4. But don't forget that it's negative 3 and negative 4. 5 up there should have been negative 2. So that one will go, we'll put it below just because we're running out of space. So you'll notice the square root isn't necessarily, so let's say the square root of 5, that doesn't go on the 5. You've got to figure out what 2 whole numbers it falls between, and that's by taking the square root. If you use a calculator to find all these square roots, the decimals would fall in between those 2 numbers that we put it on. So for example, the square root of 5 as a decimal is somewhere between 2 and 3. It's just not a perfect decimal. So we're using the integers that they lie between to put them on the number line. All right, graph each of these decimals on the number line. Well, one thing that's easy is I know negatives, they're all as one group, so let me ungroup these. Maybe we'll leave them grouped, I'll just rate them, that's okay. So negative 2.5. The tricky thing with negatives is always figuring out, does that go between negative 2 and negative 3, or negative 1 and negative 2? If it's negative 2 point something, it goes in between negative 2 and negative 3. So it'll go to the left of it if it's negative 2 and something more. 1.75 is bigger than 1, but it's smaller than 2. So I'll put 1.75. 4.5 is bigger than 4, but smaller than 5. 4.5 actually goes right in the middle. Negative 4.1, it's negative 4 and a little bit more, so that's going to go right here, in between the negative 4 and the negative 5. If it went in between the negative 3 and the negative 4, it'd have to be negative 3 point something. 3.2 is a little bit bigger than 3. Negative 1.25 is a little bit smaller than negative 1, so it goes right here. The positives aren't too bad, it's the negatives that are tricky on these examples. All right, which decimals are graphed below? Well, first of all, our dot is located between 2 and 3. So that means it's going to be 2 point something. We're not quite at 3 yet, so it's not 3. It's in between 2 and 3, so it's 2 point something. Then I'm going to count how many lines I have. 1, don't count the 2, so 1, 2, 3, 4, 5. So 4 out of 5, we've got to figure out what that is as a decimal. So I have to do some long division here. So I always say 4 is my numerator, my nerd. The nerd likes to go inside the house and play video games. The denominator is the dog, the 5 that has to go outside of the house. Now 5 can't go into 4, so I have to turn that into a 40. 5 can go into 40 8 times, so 5 times 8 is 40, which subtracts to get 0, so it's 0.8. 2.8 is my answer. On the next one, we have a dot in between 1 and 2, so it's going to be 1 point something. Count the number of lines I have, don't count the 1, but 1, 2, 3, 4. So that one is 3/4. Hopefully, if you can think about money, if you, out of 4 quarters, you have 3/4, that's 75 cents, so 0.75. And then on this bottom one, 1 and 2, my dot's between, so it's 1 point something. Don't count the 1, start on the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7/10. Anything over 10 is point whatever the top number was. So 6 out of 10 would be 0.6. 4 out of 10 would be 0.4. So this is 1.7. So here are my 3 answers. Graph each of these fractions on a number line. All right. So let's start with, let's start, oops, I just ungrouped that. Let me group it together again before I continue. Oops. That one got ungrouped too, I think. Okay, so let's group these together again. Okay. Let's start with the positives because they're easier. 1 1/2. That one's not too bad. 1 1/2 goes in between 1 and 2. 2 3/4. 2 and a little bit more, so it goes in between 2 and 3. 3 2/3 is a little bit more than 3, so it goes in between 3 and 4. 4 7/10 is a little bit bigger than 4, so it goes between 4 and 5. Okay, now we're left with negatives. Negative 1 1/5 would go, it's a little bit smaller than negative 1. So it's negative 1 and a little bit more, so it should go between negative 1 and negative 2. Negative 4 and a little more goes between negative 4 and negative 5. Negative 2 and a little more goes between negative 2 and negative 3. Negative 3 and a little bit more goes between negative 3 and negative 4. Remember, if I move this here, that means it's between negative 2 and negative 3, which would not be right. So it's got to be over here. Which fractions are graphed below? So we have a 2 and we have a 3. So it's going to be 2 and something. This is 1, 2, 3, 4, 5. So 4/5. The fraction ones are easier than the decimal ones, that's for sure. All right, this one's between 2 and 3. So it's 2 and 1, 2, 3, 4. So 1/4. And this last one is between 1 and 2. So it's 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3/10. So just the top number where the dot is over how many lines there were. Summary. Your homework for this lesson is worksheets.